3. Again, if you saw the last one, 22 was a natural log integration. We're going to kind of do the same thing here, remembering again with integration, it's a sort of a backwards forwards process. So what we're really looking for is we're trying to think of something that if we took its derivative, this is what we would get. Okay, and hopefully we remember that when we take derivatives of e to the x, it really is its own derivative. So I'm going to play a little bit and then I'll show you a direct way we can actually get it as well. So we're thinking, okay, let's see, 8x plus 3. If I were to take that derivative, what do I get? Well, I'm going to get itself. And then remember the chain rule, I've got to take the derivative of the inside. Usually I do that first, times 8. Because especially with e to the x, we put it first. This is what I get. It's close to what I got here, but I don't have that 8. So what if I just divided by 8? Right, so what if I had this? What if I had it? So if I integrate it and I start with 8x plus 3 divided by 8. Well, now when I take its derivative, I get the same thing, e to the 8x plus 3 divided by 8. But when I do its chain rule part, I take the derivative of the exponent. I get my 8, and boom, look at the beauty. 8 divided by 8 is 1. I got now what I started with. So that what it's telling me is that this will integrate to e to the 8x plus 3 over 8. Okay, that's all. That's end of story. However, I'm going to show you the straightforward sort of techniques that get used to do this on a regular basis. You know, the u substitution, which in my estimation can become very cumbersome. It's a whole process to learn in itself, but there are times when we don't see this, and there's times when that exponent's a little bit more complicated, and using the u substitution is helpful. So if you're satisfied, great, move forward. If you'd like to see the u substitution, stick around. It's not costing any extra money here. So the idea is u substitution is when we want to integrate, we make the exponent here, we make that a new letter. We just say, okay, let's group this into something. Let's call it a function, whatever. Let's call it u. That's why. And why u, I don't know. Somebody decided that was a good letter to use. Okay. Now we've got our u, so we're going to substitute. So it's going to become e to the u. We still got this dx. So what is dx? Well, we've got to take the derivative of both sides. Du. Derivative of this side is going to be 8 and dx, because we took the derivative of x. Divide both sides by 8. See what we got? See where that 8 comes from? So here it cancels. So dx is equal to du over 8. And so we replace this dx here with du over 8. Now when we integrate, we say, okay, e to the u, that's its, well, I usually do one more step. So I'm dividing by 8. That's a constant, so I just put it out here. Take it out, get it out of the room. It's not, nothing's going to happen to it anyway. So let's just, oh, that's so simple. E to the u is e to the u. And then we still have this 1/8 that's outside the room. Let's go ahead and bring it in. And then all we have to do now, we have integrated. I'll put my plus a constant to show that I've actually integrated it. I went through a process. Doesn't look like anything happened, but it did. I integrated e to the u, and I get e to the u. It's kind of like this, it's got such a great identity. Even through integration or differentiation, it stays the same. E to the u, and then I just back substitute. What is u? Well, it's 8x plus 3, so I put that in, and that's how I got this. Okay, so there's the u substitution. That's what's going on. But you can also I just be honest, the way I sort of understand it was when I started playing with it like this. Okay, let me just guess and check. And oh, it works this way. This made a lot more sense than the U substitution. But I tell you what, once I understood this, then the U substitution started making sense. And I was able to use it when it was more complicated and I couldn't get it by guess and check anymore. Okay, so we'll keep moving forward and almost there. A few more, right? Thanks.